Welcome to another engaging episode of the Virtual Reality Reconstructionist. I'm Roger Ryan Ryder, your host, and today we are embarking on an in-depth journey into the cutting-edge technology that is revolutionizing forensic investigations in active shooter scenarios, LiDAR scanning. Imagine a scenario where a community is devastated by an active shooter incident, much like the tragic events that unfolded at a bowling alley and restaurant in Lewiston, Maine on October 25th, 2023. These heartbreaking events emphasize the critical need for advanced investigation tools, and LiDAR scanning has emerged as a powerful ally for law enforcement and forensic experts. In this episode, we'll delve into the intricacies of LiDAR scanning, its applications, the impact it has on solving crimes, and the exciting potential it holds for the future of public safety and investigations. To fully comprehend the power of LiDAR in active shooter scenarios, it's crucial to begin by unraveling the technology's fundamental principles. LiDAR, an acronym for light detection and ranging, is a remote sensing method that employs laser light to measure distances with remarkable precision. In the context of forensic investigations, LiDAR scanners are positioned at crime scenes to capture highly detailed 3D point clouds. This point cloud serves as the building block for reconstructing incidents with extraordinary accuracy. By emitting laser beams and measuring the time it takes for them to return after hitting an object or surface, LiDAR scanners can generate data in 3 dimensions. In an active shooter scenario, the role of LiDAR scanning becomes pivotal. The ability to capture the comprehensive data on these positions, movements, and directions of objects and individuals within the crime scene can be a game changer. The resulting point cloud provides a wealth of information, offering investigators a 3D representation of the entire scene. However, a single LiDAR scanner position provides only a partial view of the scene, most like traditional 2D video footage. The true potential of LiDAR emerges when the scanner is moved around to capture point clouds from various angles. These individual point clouds can be merged to construct an all-encompassing, highly accurate 3D map of the space under investigation. LiDAR scanning is a versatile technology with numerous applications in active shooter scenarios and beyond. Let's explore some of the key roles it plays. The primary application of LiDAR scanning in active shooter scenarios is crime scene reconstruction. In the aftermath of a tragic incident, investigators can deploy LiDAR scanners to capture the scene's most intricate details. From bullet trajectories to blood spatter patterns, LiDAR scans offer invaluable insights. Imagine returning to a Lewiston shooting where an active shooter wreaked havoc in a bowling alley and restaurant. LiDAR scanners could have provided law enforcement with a 3D representation of the crime scene, enabling them to determine precisely where the shooter was positioned, the path of bullets, and the movements of both victims and first responders. LiDAR scanning also excels in capturing subtle evidence that might be easily overlooked during the initial investigation. In a high-stress situation like an active shooter scenario, the ability to revisit the scene with precision can be a game changer. Items as small as shell casings or minor damage to the environment can become crucial pieces of the investigative puzzle. Determining the original bullets fired within a space is a complex task that plays a critical role in active shooter investigations. LiDAR scanning's precision comes to the fore in trajectory analysis. By capturing the scene in 3D and providing a detailed point cloud, investigators can retrace the paths of bullets and identify potential shooting positions. In the context of a Lewiston shooting, LiDAR can have been used to map the trajectories of the bullets, shedding light on where the shots were fired and from which angles. This information can be invaluable for building a comprehensive picture of the event and understanding the shooter's actions. One of the most exciting dimensions of LiDAR scanning is its synergy with virtual reality, VR. Combining LiDAR derived point clouds with VR technology can create immersive experiences with profound implications for active shooter investigations and legal proceedings. Imagine this scenario. A crime scene investigator has LiDAR scans of an active shooter incident. These scans can be converted into a virtual reality environment that replicates the entire crime scene in 3D. Now, legal professionals, jurors, and expert witnesses can step into the virtual crime scene wearing VR goggles and explore every detail. In the courtroom, this means the attorneys can present evidence in a way that goes beyond traditional 2D images or video. Jurors can actually walk through the scene, examining the position of the victims, the trajectory of the bullets, and the shooter's movements. This immersive experience can significantly impact the understanding and decision-making of these involved in the legal process. In legal proceedings related to active shooter scenarios, video evidence is already a potential tool. However, when you combine the video evidence with 3D point clouds created by LiDAR, its impact on the courtroom becomes even more significant. With LiDAR data integrated with game engines such as Unity, attorneys can create 3D incident scenes that jurors can explore as if they were physically present at the scene. This added dimension allows legal professionals to present evidence in a way that transcends the limitations of 2D imagery. As Brian O'Neill, president of the International Association of Forensics and Security Metrology, points out, they say a picture is worth 1,000 words. Well, as 3D picture video that you can move around in and look at different things is worth much more than that. However, it's essential to note that LiDAR applications in the courtroom isn't universal. It should be used selectively, deployed only when it can answer questions that other methods cannot reliably address. It's a tool of precision and accuracy, tailored to specific cases where its capabilities are indispensable. Despite its high-tech image and impressive capabilities, LiDAR scanning equipment is remarkably user-friendly. Let's explore how investigators can deploy a LiDAR technology and the considerations involved. Using LiDAR scanners at crime scenes is a relatively straightforward process. Investigators position the scanner where they want to capture data and press the scan button. From there, the laser scanner emits beams, measuring distances in 3 dimensions and creating a point cloud. In the context of active shooter scenarios, setting up a LiDAR scanner at the crime scene can be done relatively quickly. By strategically placing the scanner in different positions, investigators can efficiently capture the required data to reconstruct the incident. The challenges of LiDAR scanning typically revolve around managing the voluminous point cloud data. The resulting dataset can be massive, requiring significant computational power for processing and analysis. Inadequate hardware or software can lead to bottlenecks in the workflow, making it crucial for investigative agencies to invest in capable technology infrastructure. Another consideration is the level of detail required. In some cases, investigators may opt for a less detailed scan if they serve the purpose of the investigation, while in others, a higher level of detail is essential. These decisions must be made based on the specific needs of the case. LiDAR scanning has already made significant contributions to forensic investigations. Let's explore some real-world case studies and success stories that showcase the technology's potential. Returning to the tragic events of Lewiston, Maine on October 25, 2023, LiDAR scanning could have played a pivotal role in reconstructing an active shooter event. By setting up a laser scanner at the crime scene, investigators could have captured highly detailed point clouds. These point clouds would have been instrumental in determining the shooter's location, the trajectories of the bullets, and the movement of the victim and first responders. The comprehensive 3D representation of the scene could have provided invaluable insights for the investigation and subsequent legal proceedings. Another case where LiDAR scanning could have made a significant difference is the Pulse nightclub shooting in Orlando, Florida in 2016. During the incident, a gunman opened fire inside the nightclub, resulting in multiple casualties. LiDAR technology could have been used to capture a detailed 3D representation of the crime scene, aiding investigators in understanding the shooter's movements and the interactions of individuals during the chaotic event. The Marjory Stoneman Douglas High School shooting in Parkland, Florida in 2018 is yet another tragic event where LiDAR scanning could have played a crucial role. By creating 3D point clouds of the school's interior, investigators could have reconstructed the shooter's path, the location of the victims, and the sequence of events. This level of detail could have been immensely valuable in understanding the dynamic of the incident and ensuring a thorough investigation. LiDAR scanning is poised to play an increasingly vital role in active shooter investigations in the future. Here are some exciting prospects and developments on the horizon. As computing technology continues to advance, the processing of vast LiDAR datasets will become more efficient and accessible. This will streamline the workflow and make LiDAR scanning even more practical for investigators. LiDAR scanning can be enhanced by integrating with other technologies such as artificial intelligence and machine learning. These technologies can help automate the analysis of point cloud data, identifying patterns, and extract meaningful information more rapidly. In this episode of the Virtual Reality Reconstructionist, we've taken a deep dive into the transformative potential of LiDAR scanning in active shooter scenarios. By employing a laser scanner to capture 3D point clouds of crime scenes, law enforcement agencies can reconstruct incidents with an unprecedented level of detail within minimal error. The combination of 3D video and 3D point clouds overlaid with virtual reality technology creates an immersive experience that can significantly impact legal proceedings. However, it's crucial to recognize that LiDAR is not a one-size-fits-all solution. It should be used selectively, deployed in cases where it can answer questions that other methods cannot reliably address. As technology continues to advance, we can expect further innovations in crime scene reconstruction. LiDAR is just one example of how technology can revolutionize law enforcement and forensic investigations. Stay tuned for more exciting development in the world of virtual reality and technology. This concludes the episode of the Virtual Reality Reconstructionist. Thank you for joining us, and remember to subscribe for more insightful discussions on the evolving role of technology and crime scene reconstruction, with a special focus on the game-changing potential of LiDAR scanning. Stay safe and stay curious.